Hello and welcome to Finance World. Today we're going to have a look at quadratic equations and one of the methods to solve a quadratic equation. Now, let's first start off with what is a quadratic equation, and they typically have the form ax squared plus bx plus c is equal to 0, where a is the quadratic coefficient, b is the linear coefficient, and c is the constant. Now, a quadratic equation must have the x squared term, which implies that a cannot be equal to 0. B and C can equal to 0, which will reveal the most simple case of a quadratic equation to be x squared. And if we plot x squared onto a graph, it looks like this. Now, the quadratic equation can only have at most two solutions. There are actually a variety of ways where we can solve quadratic equations. The first method that we're going to go through in this video will be factorization. It's a little bit of trial and error. The second method will be completing the square, and the third method will be using the quadratic formula, and we will actually derive this quadratic formula later on in the series. So, suppose you are flipping through a textbook and you come across a problem which presents to you this quadratic equation of x squared plus 5x plus 6 is equal to 0, and the question asks you to factorize this particular equation. Now, to do this, we first need to find two numbers that sum to the linear coefficient b. In this case, it's positive 5, and the product of these two numbers is equal to the constant coefficient c, and in this example it's positive 6. So what are they? The first thing we can have a look at is to try 1 and 4, because we know they sum to 5, but unfortunately the product is not 6. So let's move on. Let's try 2 and 3. They sum to 5, which is good, and the product of 2 and 3 is also 6, so that's good as well. So we found our factors. Now that means we can rewrite the previous equation in this form, which is x plus 2 multiplied by x plus 3 is equal to 0. Now, that means we have reduced the quadratic equation down to a system of two linear equations. We either have x plus 2 is equal to 0, or x plus 3 is equal to 0. And this implies x is equal to either minus 2 or minus 3. Well, that's good. Well, with small numbers, that's not too difficult, I hope. So we also need to check that that works. So let's multiply it all back out again. So you have the first term, and that is x squared, and then you have 3x, and then you have 2x, and finally you have 6 is equal to 0. And then if you collect the like terms together, we arrive at x squared plus 5x plus 6. So this shows that our factors have worked, and we have factorized that equation into a system of two linear equations. Now, the purpose of it is, as I've just explained, we reduce a complex system, and that goes from a quadratic to a system of two simpler linear equations to find your solutions. So we're going to be careful, because factorization only works when the left hand side of the equation is then equal to 0 specifically, and then the factors must add up to the linear coefficient, and the product of the two factors must equal the constant. Okay, so suppose that you're now under a little bit of time pressure, and you've been given a little bit more of a difficult quadratic equation to solve, like this. So I don't think it's that easy to try and find two numbers that sum up to 12, and the product of the two numbers is equal to 6. Well, if you did that, that's brilliant. So what we're going to do is we're going to show you a new method in the next lesson, and that is completing the square. So that will be on the agenda to follow in the next lesson. Following completing the square, we'll also try and tie it up to a real life example where we may use this. And then we will also look at deriving the quadratic formula, and then we are going to inspect the discriminant of the quadratic formula, as that tells us some key information about the quadratic equation that you are solving. Following that, we are going to take a quick first steps into geometry, because graphical representation of equations is very essential in real life. Perhaps you might want to find a relationship between the two variables that you are exploring, which is related by the equation that you are looking to solve. And perhaps you are looking for a more statistical approach to your data set. Now, what we are going to follow that up with is angles in general, plus trigonometry, as trigonometry is a very fundamental mathematical concept and it's applied in a large number of areas, which will be explored later on in the course. Now, we'll also have a look at calculus, which is a very applied mathematical branch of geometry, I would say. It's kind of like finding tangents to your graphical solutions. We'll do this from first principles, and we'll also explore infinitesimal calculus, which is the same as differential calculus. What this does is, with the tangent that you are deriving from first principles, we are able to give that in form of an equation as well, which will be very useful, especially if you're trying to look at a first order derivative type of relationship between two variables. So if you like the content and you look forward to the upcoming content, please like and subscribe and leave a comment down below, and we can discuss any concepts that we've discussed that you're unsure of. And otherwise, please stay tuned and peace out.